in here.
All right.
I was so sad.
You know, you
Now that I'm up, you can take
know,
my
but then there was that back.
I want you to camera.
You are very like not slide.
One of those. How are you?
Okay, everyone get settled in? Everyone ready? Oh, yeah, that's again. Everyone ready?
Yes.
Yeah.
All right, Joe Carlson's here. I was technical lead.
Yeah, I can
Technical
intro
at
myself.
BestBuy.com, and I'm done talking about it because he wants to talk about something.
Thank you.
Yay!
Yeah, first of all, thank you for being here. This is great. So, quick introduction about myself. I'm Joe Carlson. I'm technical lead for BestBuy.com. I'm in charge of like the front end architecture, basically. We're the third largest e-commerce site in North America. Just beat Target this year. No shade. And then, yeah, so let's see here. A little bit of my background too. I was the lead technical instructor at a dev development bootcamp in Honolulu, Hawaii for 3 years. It's a similar prime. So that's cool. So I have a lot of experience working with bootcamp grads, students, people in your like non-technical or like non-traditional programmers, right? Okay, cool. Right now too, I do a lot of public speaking. So I travel around the world, give tech talks. I mostly speak about front end, performance, React. I also do a lot of stuff on kind of introducing CS theory to bootcamp grads, people who like didn't necessarily have that as a background. So big O notation, algorithms, data structures, that sort of thing too. So I want to be like the non-scary entry point to a lot of the scarier parts of programming. Okay, cool. So I'm going to be talking about Async-Await a little bit today. I think I have like 30-ish minutes. We'll kind of see how it goes, how much we're getting into it. But a couple things I want to set before we jump into it is we're going to be jumping to promises. My understanding, you guys know a little bit about them. It's a couple weeks ago. I know in bootcamp years, that's like a million years ago. So things may be a little foggy. So that's fine. The other thing, too, is make sure you ask lots of questions, too. I think we'll be saving some time at the end for questions. But I usually find that asking questions in the moment is a little better. We're like in it. We can like explore it, whatever. So we can kind of check it out. Okay, cool. Let's see here. Any questions? Any questions? Okay.
Can you make the text bigger?
I can. Yes. Yeah, I will definitely do that. Thank you. Other things too. I'll be posting resources, and I'm also recording this video too, so I'll be posting that on my website later on too. So if you want to check that out too, that's great too. Okay. All right. Let's just start. So promises. Can you tell me what a promise is? What's maybe let's start with it. Like, what problem was promises trying to fix?
Asynchronous when stuff happens at the same time when
Yes.
you don't want it to.
Yes, the asynchronous stuff. Yep. What was the first way we learned for dealing with asynchronous stuff in JavaScript?
Then.
Not that. That's a promise. Starts with a CB. Cheeseburgers. Callbacks. Callbacks. Right. Click event right in the DOM. Right. You have some sort of event handler. Click on something. Right. Invokes some sort of function. Right. But callbacks. We've been dealing with callbacks for forever. Maybe we forgot about them now. Why do we need promises if we already have callbacks for handling asynchronous events?
So make sure they run after each other.
Sure, we can still deal with callback functions. And how do we do that? How do we make sure that things are happening the right order with callback functions?
That's just the order in which it's written.
Yes. Yes.
If you,
Let's say we want to go to a database and go get some data, and then we want to go and make an API call after we get that data. How do we do that with callbacks?
that would happen in the promise.
This is pre-promises. Pre-promises. It gets something. We're getting to. You guys familiar with the concept of callback hell? You guys heard that before?
Callback hell?
Callback hell. Yes.
Hell?
Yes. Yep. I know, right? It's a thing. Let me see if I can figure out my monitor here. What? Everything
In
just
fairness,
disappeared.
it's a fate we didn't put you through.
Yeah. No, and you guys may miss it too. Like this is like Node is written with callbacks in mind. I think I just lost my browser. Let me anyway, callback calls. You know what, whatever. I'll just stub it out here. So like callback calls is like when you have like some sort of database call, and then you have to nest it. Yep.
You made your terminal bigger.
right?
Yeah, that's good.
And then we have some sort of another thing inside of it, and then we have this. I call it like a flying geese formation, where you start having callbacks and callbacks and callbacks to make sure they're. And this might be a little hard. The reason promises came in because they solved a very important problem of basically solving callback hell. So if you have deeply nested asynchronous events, promises basically linearize it, make it a little bit easier to handle stuff. In my experience too, promises also make it a little bit more beginner friendly because they kind of straighten it out. Because right, if you want to do error handling inside these callbacks, you usually have like data right, node that's usually the standard formation or standard notation. You have to do like if then handle error or whatever, do handle error, right? And then we do something. It's hard to read, then do stuff if it passes, like, and you have to keep doing that over and over and over and over again, which is just like a huge mess. Like looks ugly and it's gross and it's hard to read. Ugh. So
Thank you for not making us do that.
yeah, yeah. So what promises? So we want to convert a promise, right? This is just a high level promise thing. So promises. Tell you what, let's do a promise together. Let me see. I've lost my thing here. Let me pull up the browser again. Where is it? Put that. Okay, so let's actually, what we're going to do is write some promises, kind of explore them a little bit, and then we're going to convert them async-await, talk about why we do that, and kind of where that starts. So, first thing I want to do is write a couple functions. We're going to do resolve after 2 seconds, and again, yell if I'm going too fast or starting slow promise, and so return new promise. Does anyone know why we have the new there?
New instance of
Yeah, yep. It's instantiating a new instance of the promise class. Right? You can do that with any primitive in JavaScript, arrays, objects, whatever. Not good practice to do it, but that's how you instantiate a new instance of a promise. Right? You could do new objects, capital O, right? Okay, so great. And set timeout. And we want to do it for 2 seconds. What does resolve do on a promise?
Stop
It does, yep. It stops it. Yep. No, think of it as like a return for promises, but return statements end everything that happens underneath of it. Resolves do not. So that's why I can console log after it, but minor differences.
So Joe,
But-
we've used promises before. Could you walk them through creating a promise? Because I don't think anyone's done
Yeah, sure, absolutely. Like besides, like how this works, this new instantiating a new instance of it, or
Yeah, and how the timeout is going to impact this. I guess you're not done with it.
yeah, absolutely, yep, yep, yeah. Thank you for. Yeah, there are things that you may not know or already covered that I don't know, so you guys have greater context on that than I do. So thank you. And then I need to set this timeout, and we're going to do 2,000 milliseconds. Okay, cool. So can you tell me what's going on with this promise? What does this promise do?
It's going to console log. Slow promise is done.
Mhm.
After 20 seconds,
Not 20,
2,000.
2 seconds, yeah. So how set timeout works is it's a callback function, a cheeseburger, CDs, right? It invokes this function after this many milliseconds, 2,000 milliseconds. So it's going to run this anonymous callback function, and the resolve again is like a promise way of saying return. So like, and we need to set that because we need to tell this promise when it's done. The program's going to wait until that resolve is met, and it's going to find that after 2,000 milliseconds, or 2 seconds.
After 2,000 seconds, it's going to return
2,000
20.
milliseconds. Yep. Yeah, it's gonna. Yeah, exactly. And then we're gonna call like slow promise is done. Okay.
Why 20?
What's that?
Is that just, that could be anything, but you chose 20?
Yeah, it could be anything we could do.
Okay.
Let's do it reserved. So this is when in the thenable, that data that gets returned, like then I'll show you how to use it. So let's actually let's go ahead and do this. So I'm gonna invoke this I want to get access to this data, so resolve after 2 seconds. Okay, so how do I use this promise? How do I use this? How do I get this data? This 2. You can. How do you get it with promises? Dot then, yes, and then dot then it takes a single argument. So let's do that. Dot then takes one argument. What is that? How do you get access to that juicy data? Response. Yep. What's the data type of the response? What is that? Close. Everything's an object in JavaScript. So technically yes. Yes.
Wouldn't the function go in there?
Yes, a function, a callback function. So we need to have some sort of code that runs after this promise is resolved. So typically how that's done, we'll do something like data. This is the data that gets resolved, and then let's just pass that through. We want to like console log data. All right, so we have a thenable. The thenable has a single argument, which is a callback function.
Sorry, what is a thenable?
Thenable. So thenable is what we call like a chained. Anything that's
thenable.
Thenable is like anything that returns a promise is like thenable, so you can return .then on that promise. So we call those thenables. Or at least I do. I don't know if that's a thing, but so great. Let's take a look. Let's see if this works. Okay. And async. Starting slow promise 1, 2. Return slow promise is done, and then we console log data here. That's the returned resolve statement from this promise on line 5. That makes sense. So again, we go through that starting slow promise. The promise starts. Wait 2 seconds. I'm going to refresh it. You can see it. Starting slow promise. 2. Then promise is done. Then it immediately resolves that thenable in this console log here. Maybe I'll put a little. Let's put a flag on there. So we'll do like thenable. So now you can see that 2 is coming from the thenable, which is resolved on. Okay. Cool. One last piece. What if there's an error in here? We always got to deal with errors. Programmers, we always got to be worrying about what's the edge case. Happy path is great, but as programmers, we should always worrying about what happens if this fails. Venables and promises, how do you capture errors? Dot catch. That's right. So let's just go ahead and throw one of those on there. Dot catch. We're going to do the same thing. We'll just do a. Actually, we can just do this console. We could do the same thing here too. Just do a console log. Okay. Venables 2. If you use fat arrow notation, it immediately invokes that function. It'll immediately invoke the function in there and pass through the data. It's a little hack on there too. So you can still see. Oh, that's not going
Can
through.
you repeat that last part?
So if, for example, right, this thenable, I have an uninvoked console log. On a thenable statement, you can pass that through, and when the thenable is invoked, it'll invoke the function inside of it, and actually console log it. So
Okay.
it's a little promise hack you could do again. So we're just doing console logging and erroring it. I wouldn't recommend it unless you like know what you're doing, but just want to kind of show you a little secret hack promises. Okay, cool. Great, we got data thing passing through. Cool. Okay. Any question about promises so far? Is this stuff like what new, or like is this like kind of remember it?
It's pretty new. We mostly use Ajax.
Okay.
Yeah.
But
Cool.
I do get what's happening.
Yes, but so Ajax is inherently asynchronous. How does that like? How do you get that data back from an Ajax request with jQuery? I assume.
Yeah.
Yeah. So how does that's asynchronous, just like this stuff. How are we getting that back?
We do the Ajax request, send it with a get to the URL, and it sends us back a response.
Right. So how do we get that data? Like this. Oops. Sorry.
In our .then.
Is it venable? Yeah. I guess it's been a while since I used jQuery, but yeah, it's either or callback function. I'm getting nuts over here. So
It's both.
Cool.
It can be either.
Sure. Cool. All right, let's do one more thing. I'm gonna do make a separate promise, and let's make it a fast one. Fast one. Fast. Okay. So So what I want to do is I want to do my slow one, then do my fast promise in that order. How do I do that?
You just milliseconds.
What's that?
Change the milliseconds.
Oh yeah, thank you. That's now we actually need to make it go fast. But I want to go. So it's going to do slow promise first. Then when that's done, I want to do a fast promise. And you need to make sure it's very important this application that happens in that exact order. How do I do that?
Resolve after 2 seconds. Then resolve after 1 second.
That's right. Yep. Actually, we should do that 1 second. Instead of console logging here. Now we should invoke the second function after that. So once we've resolved that slow promise, then we resolve the fast promise. And let's see if that works. So starting slow promise, great. Starting fast promise, awesome. Fast promise looks like, yep, slow promise is done. Starting fast, then fast completes, as expected. Yeah, we've made sure that those things happen in the right order. Yeah.
What tells it what error to put in the catch?
Ah.
Like you didn't return any error or anything.
Yeah.
How does it know what to put there?
Love it. So we didn't program it at all, but let's do it. So instead of doing a resolve, you can do a reject. So you can code in there when you want it to actually fail. So typically you have error handlers in there. Oops. And then, oops, that screwed that up, but we can fix it. So let's do that instead. So instead of a resolve, let's do a reject. And we're going to say something bad happened. Okay? So on the fast promise now, we're going to instead reject it. And then now that catch should be caught down here in the console error. So let's see if that works. And you can see here, oops, unhandled exception. Let's make that bigger. Something bad happened. So now we're catching that down here. So resolve or reject is basically. And as a programmer, as an application developer, we are responsible for telling the application when it should or should not fail.
But when we console log the error, it says unhandled promise rejection. Does it just know that that was the error and it console logs that for it?
Yeah, so there's different kind of error data types. You can set like data type problems, type errors, whatever. There's like a million different kinds of errors you can pass through. I'm not specifying the error code, so it's just a generic error.
So it
message.
just grabs something and says, "This is there is an error."
Yeah, exactly.
Gotcha.
Does reject work exactly like return, where it will stop the function there and it won't do anything below?
It doesn't. Well, it depends on your program. It's like right now, since we were unable to recover from it, so the application just crashes, which is why we can't do it. But like I said, resolves and rejects, they still continue. They don't work the same way as the return statements. They can work a little bit differently.
So that console log could possibly still run after.
Yeah, exactly. We could do it if we handled it that way. Typically rejects, you want it to just like be handled by you have some catch statement that handles the error, and you can gracefully handle that somehow, like send out a friendly error message or retry it or do data validation or something on it, try to recover gracefully from it.
So if it broke, we could just retry it again?
Yeah, you can. And that's a common way to do it. Maybe you want to try 3 or 4 times, depending on how long you want your client or your customer to wait.
Yeah.
Or you just secretly do it in the background. A lot of companies, it's called optimistic loading. So like, for example, if you use Facebook Messenger or something, you type a message and it looks like it appears like it went through on your screen, but maybe it failed on the back end traveling through the internet tubes, and they'll let you know later on, like, whoops, it looked like that went through to you, but we tried 4 times, but it actually failed, so we may want to try it again later.
So it's like when a buffer loads to 25%, it actually didn't load anything.
Yeah, it just like tricks your brain into thinking it. Sometimes performance is about just tricking users and thinking things are going faster, even though they're not. Sometimes it's about making it actually go faster, but it's a lot about perception too. Okay. Great. Okay. So, promises. This review, promises are great. They solve callback problems, specifically callback hell, which means like reading code and error messages is kind of tricky. Remember those if errors, then do this, then actually do the real stuff. Like it gets really blocky. This is actually like pretty human readable. Resolve 2 seconds, then resolve after 1 second, and then catch errors at the end. Like that's pretty like even a new developer, you can like kind of figure out what's going on, right? Like you may not know the details, like what's going on behind the scenes. That's fine, but like high level, I could show like my non-technical boss this and be like, okay, great, I kind of get what this application is doing, right? Do this, and everything breaks, then catch it with this function or whatever. Okay, cool. So solve some readability issues. And then now I got this other thing, Async-Await. What? So first of all, does anyone ever heard of Async-Await? Anyone know anything about it? Any rumors they've heard about it? So I'll give you a little history too. Promises have been around for a couple years now. I've been using them forever with Babel. I think they became native like a year or two ago, so they're still pretty new. Async-Await just started going. I tried moving it into Best Buy's production code base probably about a year and a half ago, and I had a bunch of legacy browser issues. We ended up pulling it. We are starting to use it again because it's more widely supported now. Point is, it's native to most browsers, and it's pretty widely supported, and it's a new paradigm. I do want to make a huge note here too. I think a lot of people think like Async-Await is like the new promise. It's not. And I'm going to show you why. So Async-Await is another tool for resolving promises, and they solve the problem of making promises even more readable than before. Okay. Cool. So first of all, promise or Async-Await is Syntactic Sugar. Have you guys heard that term before? Syntactic Sugar. Think of it, Syntactic Sugar is like a term we use for when we make something easier to type and understand, but it's doing something more complicated behind the scenes. So if you guys learned object-oriented programming with JavaScript, you know, like classes and whatever, that's Syntactic Sugar for prototypes. So JavaScript supports object-oriented programming through prototypical inheritance. But you don't know that because it handles all that behind the scenes for you. Same thing here. Async-Await is the Syntactic Sugar for promises. And Async-Await statements still resolve the same thing. They just even look even cleaner and prettier. They look more like, because Venables are like kind of weird. You probably, if you're like just starting with programming, like these Venable statements are kind of weird. We're used to callbacks, but like you don't see this pattern too often in JavaScript. Async-Await's more of a pattern you're probably used to with imperative programming. So what we're going to do is we're basically going to convert this statement that we're doing into an Async-Await statement and explore some edge cases and try to break stuff. Okay. So let's see here. Let's do the same thing. So let's convert this into a let's write a new function. Const. We'll call this like concurrent start. Actually, maybe we'll call this like slow then fast. So we'll do the same thing. We want to do slow, and then after that's completed, we want to do it fast. So slow then fast. Oops. Okay, cool. So Async-Await. Okay, so this is kind of cool. So this is going to look kind of weird, and there's going to be some weird anti-patterns. It took me a while to honestly get used to some of the patterns with Async-Await, because you guys remember the word code smells, and like code doesn't look right. It did some stuff that didn't feel right for me, but now I'm like getting more comfortable with. So to do this, we basically need to tell the function that it's asynchronous. So to do that, you just type async before the function call. And then in here, once you do that, it unlocks this thing, this reserved keyword called await. And what it does is, just like you normally would, it'll wait to the statement before it finishes, before it continues to the next line. Just like you're used to with normal imperative programming, right? It does this line, then it does this line, it does this line. So Async-Await, I'll draw it up here and you can see what it looks like. So we'll do like const slow is equal to await. And then let's do the slow function here. Yes. So what this is doing then is it's going to, we're telling this function that we're writing here is asynchronous. We just got to wait for it. And now that means that we can start using these await statements back here. Once we do this, it starts working like an imperative programming. Like it'll wait for those previous statements, even though it's a promise, even though it's asynchronous. So let's do this again. We'll do fast, await, and resolve after 1 second. Oops. Okay, so let's actually see how this goes. Go slow. Okay, so when I do programming, especially when exploring new stuff, I like to make a little hypothesis, little tests, and then test them out to see if we're right. Helps me make sure that my understanding's on the right track. Instead of just, I think when I first started programming, I just started wildly trying stuff, and I didn't know what I was doing, and I didn't know if I was right or not. It helped for me to kind of slow down. and kind of,
I still do that.
and that's fine. I do it too. I've been doing it. I get it. Like, you guys only do this a couple months. That's totally fine. But I would encourage you to like slow down and try to like get behind it and figure it out and make guesses about what's gonna happen. If you're totally wrong, that's okay. I find too when I do these live codings, I'm wrong a lot of the time too. I'm kind of hoping I'm wrong sometime today too. That's fine. But we just want to make a test and see if it's working the way we think it's working. So my hypothesis is that it's gonna say slow and fast, even though this should be resolving at the same time, right? Or like should be resolving faster. We should still see the right things execute in the right order. So let's test it. Let's see. Okay, and save. Oh, anyone know the problem here? Why do I not see anything here? I didn't invoke the function. Thank you. Yes. So let's do that. Let's go ahead and invoke that function. Starting slow. Slow completes, and then we still have the reject on there. We have to do the solve. Oh, and then we have to also do. Let's do a not bad. Starting slow completes. Starting fast promise, and then the fast completes.
So it's just running through it as it's written in that line.
Yeah.
Run. Oh wow.
Yeah.
Okay.
Yeah. So note like that. Oh, I should have deleted it. That statement, that Venable statement I did before, is just doing exactly the same thing. It's just like more what you're used to, right? It does this, then this, like that. Just looks and feels cleaner.
Just looks nicer.
Yeah. So that's kind of what it is. Couple more things though. Let's try to check some more stuff out.
Could you just cover React real quick?
Yeah. That's tomorrow. That'll be tomorrow. Yeah. Are you guys just starting in React? About a week. It takes a while to get into. I've been teaching React for about 4 years. I've been traveling. Last year I toured big time with a bunch of React talks. Yeah, it's a doozy, but.
I have a question about this slow and fast.
Yeah.
Will that also work with loops? Like if you have a loop and then inside the loop you have an await?
Yeah, absolutely. So if you have a loop and you keep looping something, and you have a promise that it keeps doing every loop, it'll like hold and wait for that promise to finish, and then do the next iteration loop. Holds, right? It's just like you could do something like that, or you could have the whole loop. It has to go through the whole thing, then resolve the promise, right? Wherever you put that reject statement or that resolve statement, to kind of that promise completes. Okay, cool. So we're missing something. We're missing something here. Let's get to it. The errors, error handling. We had those catches before. What? How do we handle errors with? So something happens in slow. What the heck do we do? This I don't expect you to know, so I'm just going to tell you. And this is the part I actually had the hardest problem with getting from like a code cleanliness perspective. But best practice for handling Async-Await or errors is through try catches. I personally hate try catches. I never use them. I think they're anti-pattern. Shouldn't be used because usually it means sloppy handling. If like you don't know what the error is, and you just have a try catch on it. Like usually it means you're missing something in the code. And I'd probably, if I had a PR for one of those, I'd probably send it back. But Async-Await, that's how you catch errors. So if you want to do the same thing we were doing before, we're going to wrap this entire statement with a try. Oops, that didn't go through. There we go. And then catch, rewrap, just do like a console.error. So now if we reject this, it should catch this in the error down here. Okay, so we reject now on the fast promise, and now we see that error is being caught handed down here in the catch statement. Cool. So there's no more catches for Async-Await. You're now using try catches.
Could you explain try catch a little bit? Because we haven't gone over that at all.
Yeah, I know. That's probably good. I didn't cover it either when I taught either. Because you shouldn't be using them.
We'll get there next week.
Yeah. So try catches, that's like what it sounds like. It'll say like anything in this statement, try this, and if anything fails in here, then we just catch the error.
Will it be the same error no matter which one?
No. So for example, we're rejecting this one here. You can see error, and then we're passing through that error that we're rejecting.
Oh.
So it's whatever you pass through to that reject statement is the error.
But if it broke for some other reason, it wouldn't know what the error
yeah, you as an application developer, you're responsible for kind of telling the application why it failed.
And that's why,
Database care, improper user input, whatever it is, right?
is that why they're not great? Because it doesn't specify an error and instead just goes something broke.
I mean, we did the same thing with catches, and this is like fine too. Like I said, I don't like try catches for different reasons, and this is like if you go to NDN, like the official specification, this is how like they intended for error catching to be handled. I just think it's generally an anti-pattern that should be avoided if at all possible outside of Async-Await.
What's an anti-pattern?
Anti-pattern, like a pattern is like something a good like you probably know in JavaScript. There's a ton of different ways to do whatever you want. And that's great. It leads to a lot of freedom, exploration, but it also means that you can do stuff that is really bad that can break the code. It does it. There's no guardrails.
Nesting for
Yeah, like callback hell, like a couple callbacks is fine. But if you have like 16 callbacks, it's like really bad. Or if you're using using the abstract equality, the 2 equal signs instead of 3, like that's an anti-pattern. I don't want to do that. Or yeah, there's a bunch, right? It's basically anything that's bad, like or quote unquote not good. Coding, not clean. And that takes a long time to learn what is clean and not clean, and we can talk about that too. I do a lot of, I peruse my favorite open source projects. Humans are really good at pattern matching. Kind of looking at good code is a good way to kind of get that ingrained. That's why I talk about code smells. Like just look at a code base and like, I don't know what it is right away. Just like something looks off because they're not following best practices. It kind of takes years to kind of develop that sense of what's good and bad. Okay, cool. So, so I promised you, I told you that Async-Await is not a replacement for promises. You still need promises in your arsenal. I'm going to show you why right now. So, what if I wanted to write a statement that that completes when both of these are complete, and I want to return at the same time. So, like, I don't care. I don't like this specific example. I know these are going to take 1 and 2 seconds, but most of the time, our asynchronous events, we don't know how long it's going to take. I don't know how long the database call is going to take. I don't know how long it's going to be before a user clicks on the DOM. I don't know how long it's going to take for the API to come back. I don't know. Could be a millisecond, could be 40 seconds. I don't know. But all I care about is I want to do something when all that data from all these different sources is back into my application. How do I do that? How would I do that? Thens, yes. 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 It will be a thenable, but it's a specific kind of thenable, which we haven't really talked about yet. There's a lot of different kinds of promises, but so let's do. Actually, let me show you. Let me set up a load case here. So let's do a. I'm going to call this const concurrent finish. So I want this to resolve when both of these promises are finished. Like whoever finishes first, I don't care. I don't care what order they go out into the world. I just want to blast both these API calls out, and whenever they both come back with data, just move on. That's all I care about. So let's pretend that these are API calls. You don't know how to do that? You're mumbling over there.
Do another async with slow then fast inside of it?
Sure. So if we did like, so how would it be different than this one?
Then the one up there, it have constant set to something, and then equals await slow then fast, and then we put another thing below it once that async is done, we'll run something else.
So that will do that, but you're still sending out the one of them first, and then you have to wait for that one to come back, then sending the other one out, which could be slow down your application more. Like if we're making 2 API calls out to 2 different services, like maybe these 2 services don't rely on each other's data at the same time. So that would you're still waiting for something. And this is the hard part with asynchronous programming. You're like, okay, who comes where and where does it go? So there's another type of promise, and it's a promise.all. You can do a promise.all. So if I was going to do something like that where I want to just send out 2 API requests, and I don't care who goes out first, I just do a promise.all, and it says like when all these promises are done, then that promise completes. So we'd do something like, where is that? Resolve after, we'll do the 2 and then resolve after 1 second. And then after a promise at all. Yeah, I'm going to do this a little bit a little bit more vertically to make use of this. And you know how to get access to that data after the promise at all. How to get access to promise. How do you get access to data on promises again? .then. Yep, .thenable. Then we have a we'll call these messages or something. So this comes back as an array in the exact order that you sent it in. So it'll show you the return statement from 2, then 1. So you get an array in the order of when you pass them through, and it resolves when when both of them resolve, however long it takes. You can send them both out concurrently, get them back. But you can't do this with Async-Await. You have to use promises still. Okay, so let's see here, messages. Let me just prove that this works real fast, and then we can get into the. I have one more thing. Messages. Okay, so this should be an array. Oh, and I'm gonna invoke this now. Oh, interesting. You know what's going on here? Messages function. So what's this returning? What's messages returning?
Objects.
Close. Close. Again, everything's an object in JavaScript, so that's functions are objects, but it's a good guess. If you just want to guess to object by the time, you're probably right. Yeah, it's an array, right? You see the bracket here? It's an array of functions. So let's get to that. Let's see here. So let's take a look at just one of them. So we're going to look at the first instance in that array. Let's see what that is. It looks like a function, but I wonder if we can just get access to it directly. Where we go after rejects. Am I doing that right?
Do you need to call the function so that you return the promise? So in the
oh,
promise
yeah.
call.
Thank you. Yes, so we have to invoke it here. Thank you. You are totally right. Yes, so we're passing through the invoke functions on there. And then, what did I, oh, there we go. Troubleshooting live. This is good. Untitled promise. I think I stole that reject up here. Resolve. There we go. So now it should work. So now we're starts the slow and the fast at the same time. You see the fast one completes before the slow one. We're blasting them both at the same time. Fast one finishes first, and then we see this 2 here right when both of them are completed. So to recap, Async-Await is syntactic sugar for promises. Async-Await is not a replacement for promises. To do many things with promises, you still need to use vanilla promises. So think of it as another tool in your tool belt for solving problems. Personally, what I do is, if possible, if my application can support Async-Await, that's the first thing I'll use. And then if I need, because it's easier to read, it's more imperative, it's more what we're used to, it's easier for new developers to kind of understand it. And then if I have a special use case like this, then I bust out just vanilla promises and start using it. One last thing I want to go over before we move on. I want to talk about what this function is and kind of how that gets used. So, so slapping this async keyword on a function changes how it works, and it does some secret stuff behind the scenes you may not know about. So I just want to make note of it. You should note that putting async on there implicitly wraps your function with a return or with a promise statement. So put another way, it basically does this, wraps your entire function with returning a new promise. So let me show you. Let me prove it to you. We're going to take our async function that we just declared, and you know what I'm going to do? Oops. I'm going to. Dang it! I didn't want to hit save there. What is this? What is invoking this? What does this function return? Where's it? I guess. Doesn't. No. So I'm going to say it again. And this is confusing. I know. I struggled with this for a long time too. So when you put an async event on it, it returns a new promise. It behind the scenes wrap your function with a new promise. So you might think it returns the data, but it doesn't. It returns a promise. All right, so let's check it out. We have our slow then fast. You see here, slow then fast, it's not returning data. It's returning a promise that's pending. What the fuck? Right? What the hell?
Christy.
So,
Slave word.
is it? Okay, cool. We're adults. That's good. Okay.
What was that word?
Yep. Just huge note here. Putting async on it turns that into a promise. So if you had additional data down the line, for example, we want to return like slow, then fast, complete. How would we get access to that return statement on that asynchronous event? How do we get access to data on a promise? .then, yeah, Venables. So we do the same thing. So we basically convert that chain into a promise to start using it. And then we have some sort of data, or we'll just do the console. Okay, and I'm gonna X that out. So now we should see slow then fast complete when this whole thing's done, as it's console logged here on line 47. And as expected, that's what we see. Okay, accessing with a Venable. Okay, cool. Let's see. Okay, let's see here. Any questions? Any questions so far? Cool. Instructors, that's about it
It all
for.
makes perfect sense. You have zero questions.
Zero
whatsoever. So somebody's gonna ask a question.
I will say this. So when I talk to, I don't expect students to like understand what's happening when I'm speaking to you. You probably go back to your desk like, oh, that makes sense, and then you like go back and you start doing. You're like, oh my god, what the hell? And that's fine. But what I would encourage you to do moving forward is if you see a promise, ask yourself if you can use Async-Await. Push yourself to use it. I think the best way to learn something is start pushing yourself to use it. Every project I do, I try to use one new technology, try to understand how that works. But I push myself to see how to use that. So if you see a promise, ask yourself if you can use it and try your best to convert it. What I would probably do too is keep it in a way that you're comfortable with. So make it a promise or whatever, and then try to convert it into Async-Await. But just push yourself to do that. Try to use it. Okay. Yes.
So I will say that the most applicable use case for Async-Await for where you're at is going to be on the server making database queries. So do an insert and then take the idea of that and do another insert in the database. So when we do recommend using this, it's usually in response to like database stuff, because next week Luke is going to talk about sagas, which will kind of replace the need for this on the client for now, but there will be uses for this on the server for sure.
Mm-hmm.
I'm actually curious about that from your perspective. Do you use Async-Await on the client as well?
Yeah, because I still use it. API calls probably the most important thing I use it for. Like, if we don't have Redux, we're just in like vanilla React or vanilla JS or whatever.
And
Because it's supported natively in the browser. You don't need any plugins, you don't need any packages. It just works in the browser. So.
is that true for every browser that Best Buy's concerned with?
Yeah, I think yeah, it still doesn't support like old versions, i.e. we've had some issues. But the polyfills are working fine now. We had some issues with polyfills earlier, but it works fine now.
Cool.
Yeah, good enough for us, basically. I can't even remember what we support. I should know. I'm a technical lead. I still don't even know what browsers we support. But it's a business. People are like, we gotta support this. I don't know. I don't care. Whatever. I probably should care more. But yeah. So we use it. We've been using it though. Okay. Yeah. Yes. Okay. Let's see here. Any other questions? How much time do I have left? Do I have 2 minutes? Anyone have like questions about like career or anything like that? My life? Or I don't know if you had something on that.
Where'd you grow up?
I grew. Oh, good. Yeah. Did I talk about? So I grew up here in the Twin Cities.
Okay.
And then I moved to Hawaii a couple years ago. I lived there for like 3 years, and I came back here and I got picked up by Best Buy. And then I went to Gustavus Adolphus College.
Oh, I was saying all of
Oh yeah,
Ooh.
enemies. Yeah, sorry.
Thanks for coming.
Yeah.
Why on earth did you come back?
I know, everyone asks that. So honestly, it's like great. I worked, there's a cool little tech community down there. I planned a bunch of hackathons. Taught, loved it. Small little community. But it's really expensive. Job market sucks unless you want to work for the DoD or hotel, which I didn't. And then, yeah, just kind of looking. And I was kind of looking to like work on it. Because I could make like small products, but I wanted to like learn how to make giant websites. That's like Best Buy was a great fit. So like now I can learn. I know to like prototype, make small stuff, but I also could scale things up to be like for Black Friday scales, right? Like,
Yeah.
what is that? That's a totally different skill, right? And that was something I was interested in learning, so pick that up. Yeah.
Is AWS a really good skill to have coming out right now?
Yeah, I think it's great. I just got SE yesterday. So the three big contenders are now Azure, GCP, Google Cloud Platform, or AWS, Amazon Web Services. Honestly, my opinion is we use AWS Azure and GCP. Most companies use a mix, and they're all good at different things. So it depends on what you're trying to solve. AWS is probably most well-known. There's a lot of jobs for it, and they also have the largest breadth of products. But Azure and GCP have really great stuff too. Like Google's really good at scaling. They did it because they're great at it. They invented a lot of the tech. And Azure's really great if you're on a Microsoft stack. Like, I don't want to say like one's good. There's no good tool. It's just like different tools solve different problems depending on the problem you have. They work differently. Yeah. Okay. Cool. I'll talk a little bit. Best Buy. We have like a minute left. We're using. So I'm in charge of the front end. We're using Express-based microservices on the front end. And each microservice is responsible for doing a server-rendered React component. So we did that so if you do server rendering, it reduces strain on the client, and we can scale things up on the servers independently. And we write a node platform that kind of stitches all these different microservices together and serves out to the client. So it's been helpful for like growing up too. But this is the first Black Friday we basically deployed the architecture that we helped develop, and we stood up. We sold it just fine. I was a little nervous this year, but we stayed up. Yeah, Walmart's cart went down, Target's cart went down, but we had no problems this year. So yeah, I don't know. That's our big day for scaling. So yeah, one more question.
What kind of stuff do junior devs do at Best Buy?
Yeah, but we have a ton. We're like scaling up for juniors right now. So I have a Trilogy dev, I have a self-taught dev, and then 2 prime grads on my team. Yeah, honestly, when I'm doing hiring for juniors, what I care about, I don't really care about what you actually know. I really don't care. I care about like what you're doing after you graduate, and I care about your willingness to learn. So like even senior devs, I just hired a senior dev. Oh, actually, all the senior devs on my team are not JavaScript. They're usually C# or whatever. There's interesting JavaScript. That's all I care about. Like, and have they demonstrated they care about it? So for example, with you guys, are you doing hackathons? Do I see you at meetups? Are you at conferences? The other thing I really hate seeing too is looking at people's GitHubs. You have those like ton of green spots, and then you graduate, and it's just gray. That hurts so bad for me. So just keep programming after you graduate too. Cool. I'll be around for a bit, fun talk, whatever. But,
Thank you, 1, 3. 1, 2, 3.
Thank you. That went really
Back to work. Thank you, Joe.
yes.
I don't know how you're wearing that jacket in here. It is warm.
Yeah. I'm always like a little sweaty, so it's like